Hello, welcome back once again. Today we have another video on the so-called topic, the integration by parts. Okay, so that is the method we're going to use, but first we need to make a u substitution. We have the integral of the cosine of ln of x dx. Okay, so let's start with the following substitution. So we're going to let u equals the natural log of x. Okay, so you need to solve for x in terms of u here. So you can see that here x is equal to e raised to the power of u. So differentiate both sides. So we get dx is equal to e raised to the power of u and then du. Okay. So this integral is equal to I. So we get here I is equal to, in terms of u, the integral of cosine of u, right? Cool. So cosine of u, because the ln of x here is equal to u. Then our dx here, don't forget dx is this, right? We substitute this for dx. So that will give us e raised to the power of u and then du. So you can see when this integral is in this form now, then we can easily make use of the integration by parts. Okay, so let's make use of the integration by parts formula or method, I mean. So we're going to let u, we have u already, so we can use y and z. So let y equals the cosine of u. So differentiate both sides, we get dy is equal to negative sine of u du. Then let's use z is equal to the integral of e to the power of u. That is the other function there, which is just e to the power of u. Then our dz here is going to be equal to e to the power of u du. Don't forget that e to the power of u is a very stubborn guy. Okay, so it's a very stubborn guy. Both the derivative and the integral still remains the same. Okay, so now with the integration by parts formula, our I is going to be equal to yz minus the integral of z dy. So you get it? So this is I is equal to yz. Yz is cosine of u multiplied by e to the power of u, which is same as e to the power of u multiplied by the cosine of u. And then minus the integral of z is just e to the power of u. Then multiply by negative sine of u du, because that is our dy, abi? Okay. So let's proceed. So with that negative sign, you know what is going on? So this is equal to e to the power of u multiplied by the cosine of u, then plus the integral of e to the power of u times the sine of u and then du. Integration by parts again, just here, right? So let's make use of our y and z. So let y equals the sine function of u, then dy is equal to the cosine of u du. And then let z equals the integral of e to the power of u, which is e to the power of u. Then the derivative of the stubborn guy remains the same, right? Okay, so our I is equal to e to the power of u cosine of u, then plus, so this one now is the one with this new integration by parts method. So we have yz, which is e to the power of u sine of u, minus the integral of z e to the power of u dy, which is cosine of u du. Oh my god, did you realize something about this? This is our I we started with, right? So let's go back and check. Don't forget, oh my god, this is cool. So look at this. This is the I we started with, right? And the I just pop up again. So this right over here is I. So add I to both sides, so get 2I is equal to e raised to the power of u multiplied by the cosine of u plus e raised to the power of u multiplied by the sine function of u, then plus c. Oh, are we even okay? Let's not just put the c yet. Okay, so we're going to put it, but not now. Okay, so divide both sides by 2, and finally we can now put the c. So we get this is equal to e raised to the power of u times the cosine of u plus e raised to the power of u times the sine of u, then everything is being divided by 2, and don't forget our constants, okay? But this is not yet our answer. Our answer needs to be in terms of x. So remember that u is equal to the natural log of x, and again we're going to substitute. So we get I is equal to e raised to the power of ln of x times the cosine of ln of x plus e raised to the power of ln of x times the sine of ln of x, then divided by 2, then plus c. E raised to the power of ln of anything will give us that thing, right? Don't forget that. So we finally get this equal to, so this is x multiplied by the cosine of ln of x, then plus x, right? So multiplied by the sine of ln of x, then divided by 2, then plus c. So we can, for the sake of convenience, so we can write this as x over 2, right? Then cosine of ln of x plus sine of ln of x, right? And then plus c. So this is our solution. If you really enjoyed the video, please kindly support the channel by subscribing. Also like, comment, and share.